Hey guys, welcome to my channel and I'm back again with another really interesting coding interview question video. This time guys, we are going to solve a very important question called as design hash set. But before I start the problem statement guys, just want to request you that if you have not yet subscribed to my channel and you want to support me, then please do subscribe and hit the bell icon for future notifications of more such programming and coding related videos. Let's get started now. So basically guys, the problem statement says that we have to design a hash set without using any built-in hash table library. So if you are familiar with the concept of hashing, it is basically a concept which looks like this. So I'm just gonna use the comment section here to actually demonstrate it to you. So basically guys, hashing is nothing but it is a set of buckets. So you can see that what I can say is that I have got 5 buckets, okay, and I have got like a list of numbers, right? So 1 2 3 4 and 5 and 6, right? But I've got only 4 buckets. So what I'm going to do, I'm going to find out the hash value of all these 4 numbers, and based upon the hash value these numbers belong to, I'm going to put them in a bucket, and in that bucket they will be stored as a linked list. So for example, for the numbers 1, it comes under a first bucket, so its hash is 1. For number 2, the hash is 2. For number 3, the hash is 3. For number 4, the hash is 4. So all of them are now accommodated in their individual buckets. But for the number 5 and 6, the hash could be different. So let's say for the number 5, the hash comes as 1. If we are using a mod function as our hashing function, then 5 mod 4 is going to be 1. So in that case, the hash of 5 will become equals to 1. It means that 5 can come in the first bucket, but because 1 is already there, so what will happen is that there will be a linked list in this bucket, and 5 is just going to be appended to that linked list. So 1 comma 5, that becomes your linked list stored in this hashing bucket, okay. Let me also write the hash value in front of these. So the hash values are going from 1 to 4 and their bucket values are these. And let's go for 6. So again, if we are using a mod as a hashing function, then for 6 the hash will become equals to 2 and it will get appended to the linked list in the second bucket, and then it will come as 2 comma 6, okay. So this is the basic concept of hashing guys, that we have got a certain number of buckets all having a hash value as their key, and based upon the hash value we just store the upcoming elements or add the upcoming elements in their corresponding buckets, okay. So now that we are clear with the hashing mechanism, let's go to the problem statement again. So I guess everybody just understand what hash set is, like how it looks like. So if we have got three functions in it, add, remove and contains, right? These are the functions which you have to design. What add function does, it just inserts the key into the hash set. So as I have shown you, it's very easy to insert the key into the hash set. All you have to do is whatever number you have, based upon your hashing function, you find out the hash, and then you go to that bucket and find out get the linked list from that bucket and append that element into that linked list, just like we appended 5 and 6. The contains function is also really straightforward guys. All we have to do is first of all find out the hash of that number, and then we have to go to that bucket. So for example, for 5 the hash is 1, so we will go to 1, and then we are just going to iterate through this linked list and find out if that number is present or not, okay. So as you can see, the time complexity has reduced in this case, because if it was not a hash set, if it was a linked list, in that case I would have been traversing all the elements, right? Also because this is a hash set, so remember guys that if you get a number like this, so if I get 2 times 6 or 2 times 5, my hash set will still look exactly the same, because set cannot have duplicate elements, okay. And then remove basically means that if I want to remove any element, then I'm just going to remove that element from that linked list. So I'm again going to calculate the hash, go to the bucket, access that linked list and remove that element from that linked list, okay. So now that we are clear with the problem statement, let's see some examples as well. You can see that there is some input here which is my hash set, because this is just initializing your hash set. And then we have got corresponding functions like add, contains, remove, etc. And for all these functions, these are the values. Okay. And then finally we have to output the hash set, how it looks like. So basically what happens is that if you are adding any element, then, or you are initializing your hash set, there is going to be no output, right? But if you are calling a contains function, there is going to be a boolean output which is true or false, that if that key is present or not. And then again the add and remove functions which are mentioned here won't return anything, but the contains function is going to return true or false. But we don't have to care about the output, guys, because we are not returning anything. We just have to create this class mention the code of these functions, and then the automatic compiler will automatically call these call this hash set, instantiate it, and then add, remove things to it and print this output. Okay. Constraints are very important here, guys. You can see that the key value goes from 0 to 10 to the power 6. Because the key value goes from 0 to 10 to the power 6, we can say that there can be like 10 to the power 6 elements that we might have to add. And at most 10 to the power 4 calls will be made to add, remove and contains. Okay. So there could be a number bigger like 10 to the power 6, and at most 10 to the power 4 calls can be made to add, remove and contains. So now we are clear with the constraints as well, and let's jump to designing our hash set. Okay, let's jump to designing our hash set. So first thing we need in a hash set is a hashing function, correct? Now one thing is we need a hashing function, and we need any sort of data structure. Obviously we cannot use a hash table, but we know the hash set kind of looks like this, right? So there are buckets, and every bucket has a linked list. So what I'm going to do, I'm going to create a hash set in which we will be having a list of lists. So the outer list is going to be these buckets, and the inner linked list is going to be these elements. So let's first write that, and then we'll also decide our hashing function. So private list of lists, and this list of lists is going to have the integer elements. So let's name it hash list, or you can also name it bucket list if you want. Now when my hash set constructor is going to be called, I'm going to instantiate it. So linked list, and there you go. Now we have to decide our hashing function, right? So what I have decided is that our hashing function is going to be something mod related. Okay, so what I'm going to do is I'm going to design 100 buckets, and we know that 10 to the power 4 calls can be made. So either you can think that yes, if 10 to the power 4 calls are made and we are adding in all those calls, then what's gonna happen? You are going to end up adding like 10 to the power 4 elements. But instead of creating 10 to the power 4 buckets, what I'm going to do is I'm going to create a 100 buckets function, and then I'm going to, whatever number I get, I'm just going to mod it with 100. Whatever key I get, I'm just going to mod it with 100, find out the hash, and then accordingly store in this hashing function, just like we did with these 6 numbers in which I have got 4 buckets. We are going to do it the same thing with 10 to the power 6 numbers with only 100 buckets. Every time we will mod that key with 100, find out the hash value, and then store that number in the linked list of that hash. Okay, obviously you can choose any number. I am choosing 100, you can choose any number. So for integer I equals to 0 to, now I am just initializing the 100 buckets. Okay, so I 0 to I less than 100. I'm just inside this hash list, I'm just going to add 100 buckets. Okay, and obviously for now none of these buckets have any keys, have any elements, so all these buckets will be having a null value, right? So initially all these buckets are empty buckets, so this like this, that I am initializing empty buckets. Okay, now my hash set is initialized. Now let's go to the add function. Now add function is very interesting. As I said before, that whenever you are adding the key, the first thing you have to do is find out the hash of that key. And what is my hashing function? My hashing function is mod 100. So key mod 100. Now I have got the hash. So the next thing is that you have to find out in this hash set which bucket we are referring to. So I'm just going to initialize the child list in which we are going to add this key element. So let me just write here child list, and the next thing is we have to find out if if the hash list has that hash or not. If the hash list dot get hash is equals to null. So what does that mean, guys? That if inside the hash list I go to that bucket, which is my hashing bucket, but that is null. If that is null, it basically means that your child list is empty, right? So it means your child list is empty. So if child list is empty, it means no element has been added. I'm just going to initialize it, right? Linked list, just going to initialize it. But if hash list dot get hash is not equals to null, it means that we have found there is some existing child list in it. So in that case, it's very simple. You just write here child list becomes equals to hash list dot get hash. So that becomes your child list, right? Now the important thing here is that now we have to add this key into my child list, right? Now remember one thing, guys, that this is a hash set. If this was a hash map, I could have just done like this, right? I could have just added my key. But no, you cannot do that. The reason being is that this is a hash set. So first you have to check if this key is present inside the child list or not. So if child list dot contains this key, so if inside that linked list that key is not present, if that key is not present, in that case we will add the key. And finally, when the child list is now added with the key, we are just going to do hash list dot set hash corresponding, we just put the child list. Okay, so in the last step, corresponding to that bucket, we have now added that linked list. Okay, so if the linked list is updated with the new key, then the bucket is also updated, right? That's how the add function will work. Now coming to the remove function. Now you'll see that whenever we want to remove a key, again the same step we have to do. First of all, we have to find out the hash of the key. So this first line I have just copied. The second thing is you want to find out the child list from that hashing bucket. Okay, so how do you find the child list? It's pretty simple. I'm just going to copy paste a few code lines here from the add function. So child list is obviously equals to hash list dot get key dot get hash. Okay, so that becomes your child list. Now inside this child list you have to remove that key, but to remove the key we first have to find if the key exists, right? So if child list dot contains the key, you simply remove it. Child list dot remove. Now you cannot, in Java you cannot just write remove key, right? Because key is an integer. So what it's gonna do, if you write key and key is let's say 2, it's gonna remove the number which is at the index 2. That you don't want. You want to remove the key element, right? So in this you just write integer dot value of, then you pass key, so that the integer object is passed and not the int primary, primary int is passed. So that becomes your remove. Now comes the contains function, and this is the main boolean function which is gonna return us some value. But again, the same thing I'm gonna do here, guys. Whenever you want to find out if a key exists inside a hash set or not, first thing you have to do is find out the hash of that key. Corresponding to that hash, you want to find out the child list inside that hash list, right? So I found the child linked list. Now inside this child linked list, I can easily check that if this child list is null or not. So if this child list is not equals to null, because if the child is in null, it means that in that bucket no key was ever added, right? So if the child list is not equals to null and child list dot contains the key, then we just return true. Otherwise we return false. Okay, so this is the implementation of add, remove and contains function. Let's test this out. Let's see if this works. So it works for one case, and when I submit it, it should work for all other cases as well. Okay, there is a function here. Okay, sorry. So contains, I think you cannot just pass a key here. Think so. Oh yeah, okay. I guess I have to write this here as well. That is my bite. So whenever you are removing a key, again we have to find out that in that list if the key is present or not, and also if that list is null or not. So if that list is not equals to null and the child list contains the key, then we remove it. If the list itself is null, it means that corresponding to that bucket, in that whole bucket there is no element. Okay, so that is my bad. That one condition we needed to add in both remove and in contains function. So here and the remove function, you need both of these conditions. And there you go, guys. Now you can see that the all the other test cases are passing. Okay, so here you can clearly see, guys, that whenever you are using add, remove or contains function, if you want to actually just find out an element, it comes down to the time complexity of order of h, in which h is the size of the bucket, right? So let's say the time complexity becomes equals to time complexity of contains function, right? Of contains function actually becomes equals to just finding out the bucket, and then from that bucket you just go to that linked list, you find out that function, right? So going to the bucket is order of 1, and then finding that function becomes equals to order of h, where h is the length of the bucket linked list. Okay, space complexity is definitely order of n for an entire hash set, because at the end of the day you are storing n elements into it, so definitely the space complexity is order of n. Okay, so that was the video, guys. I hope you guys liked this video, and I hope it was a bit informative for you. This is a very important question of designing a hash set or designing a hash map. I'll do the hash map as well in the future. But thank you so much for watching, guys. If you do like this video, then please do not forget to like this video and share this video with your friends. So YouTube algorithm actually recognizes the videos according to their likes and shares. So if you do that, it will definitely support me. If you want to see more such content, then please do subscribe to my channel and hit the bell icon for future notifications of such content. Thank you so much for watching, guys. I'll see you guys in the next video. Until then, take care and bye bye.